Algebra 2 Notes 1.4 Part 2, Solving Linear Equations and Word Problems. Go ahead and try the first two problems. The first one you're solving for x. The second one is one of those literal equations where you're solving for y. So go ahead and pause the video, see if you can try A and B. We're on page 5. All right, go ahead and check the warm-ups. The first one we needed to distribute and then add like terms. Finally, when you get x's on both sides, you need to add 2x to the other side, add 6 to the other side, and then divide by 8. For part B here, we had to get y isolated. Once you get negative 1/4 y, you can multiply by that reciprocal 4, but you also want to multiply by a negative so that you're left with just y. And then finally, I rewrote it so that it was in slope-intercept form. All right, so the lesson today, we're going to work with problems that have fractions in the problem and try to clear those fractions, as well as some word problems. So let's go ahead and look at number 1. Right away, you see that 3 for both denominators. So what you can do is take the entire problem times 3. So it's going to become 3 times x over 3 minus 2 equals 5/3 x plus 7. Then you can distribute that 3 through. So 3 times x over 3, those 3's are going to cancel, so you'll just be left with x. This one didn't have a denominator that's like over 1, so it's just 3 times negative 2 would be minus 6. Again, the 3's are going to cancel, so we're left with 5x, and then 3 times 7 would be 21. From there, just get x's on both sides. You can subtract the x to the right, subtract the 21 to the left to get negative 27 equals 4x. And then finally, you can divide by 4. So your final answer would be negative 27/4. You can leave it as an improper fraction. All right, for the second problem, notice that the denominators are not the same. You have a 3, a 2, and a 4. So what you need to do is think of like the least common multiple of 3, 2, and 4. So imagine if you were trying to get a common denominator out of 3, 2, and 4. What would we multiply at all times? 12. So we're going to take 12 times everything. Now, I wouldn't worry about distributing this 1/2 quite yet. We'll do that here in just a minute. So 12 times 2/3. So you can either, I'm just going to jot this over here, 12 times 2/3. When we multiply these two, you can either multiply across, because that's like 12 over 1, and get 24 over 3, and then simplify it to be 8. Or you can take that 3 out of the 12 to get 4, and then 4 times 2 is also 8. So 2/3 of 12 would be 8y. And then we go 12 times half, that'd be 6, but we still have that y minus 3 there. And then if I multiply that last fraction by 12, the 12 and the 4 can cancel out to just get 3, but again, we still have to leave that y plus 1 in parentheses. So this makes the problem so much easier because I don't have to work with denominators anymore. So now I'm just going to solve it just how we were doing yesterday. So we distribute the 6, distribute the 3, and then solve. So go ahead and finish that one up. I'll solve it here in a couple of seconds. All right, the y is over here on the same side, so we do what the sign says. We don't do the opposite. Now that I want to move my 3y to the other side, now I do the opposite. Minus 3y, minus 3y, and then plus 18, plus 18. Numbers on one side, variables on the other. So we get 11y equals 21. Divide by 11. Y equals 21 over 11. All right, let's go to the back. Page 6. All right, so this one we are trying to set up and solve an equation. It says find 4 consecutive integers whose sum is 50. So consecutive integers would be like numbers that come right after each other, like 1, 2, 3, 4, or 6, 7, 8, 9. Those would be consecutive integers. So we don't know what the first one is, so we're just going to call it x, and then we're going to call the second one 1 more than that. So if your first integer was 1, to get to 2, we just take 1 plus 1. So whatever x was plus 1. And then your third one would be whatever x was plus 2. And then finally, whatever x was plus 3. So that's kind of how you could set it up. You could guess and check, but sometimes that takes you longer to get to the answer. And sometimes not this one, but some problems have decimals. So that's not always the best method. All right, so then I can add up all my x's. So we have 1, 2, 3, 4x. And then add up your numbers. Plus 6 equals 50. 4x equals 44. So x is 11. Now notice that that is not quite what they're looking for. It doesn't say what is the number. It says what are all the numbers. Find the 4 numbers. So your first number would be 11. That was what x was. So now to get the next number, what is x plus 1? That would be 12, 13, and 14. You can always double check and make sure that they do add to be 50. All right, let's go to number 4. Find 2 consecutive even integers whose sum is 46. So for even integers, you can still let that first number be x, but then to get the next number that is an even number, we don't just want x plus 1. We need to go up by 2, because if your numbers were 4 and 6, we can't just say x plus 1. We had to say x plus 2. So that's going to be your second number. So you go x plus, and then the second number was x plus 2 equals 46. So go ahead and finish that one up, and then tell me what your 2 numbers are. Blank and blank. All right, we get x to be 22. So the next number, 22 plus 2, 24. Do they actually add up to be 46? Yep, they do. All right, next one. Find 3 consecutive odd integers. Now this one is set up a little bit different because it's not giving us the sum. So odd integers, we can set up the same way as those even integers. Just start with your first number being x. But now this time, if our numbers were like 3, 5, and 7, how would that work? Well, if your first number is 3, again, we just add 2 to it. We're just assuming that first number is an odd. And then the third number is plus 4, the next odd integer. So it says the sum of the largest, so this one's going to be the largest, x plus 4, sum means add, and then twice the smallest, 2 times the smallest. So that one is the smallest, that one is the largest. So we go 2 times x is equal to 25. So we go x plus 4 plus 2x equals 25. Add like terms. Move the 4 to the other side. And we get x to be 7. Okay, what are the 3 numbers? 7, 9, and 11. Okay, you can double check. Double the small one, 14, plus the large one is equal to 25. Yep, that works. All right, the last one, the width of a rectangle is 8 centimeters less than the length. The perimeter is 42 centimeters. Find the rectangle's dimensions. This one will be helpful to draw a picture. If I draw a rectangle here. There we go. The width of the rectangle is 8 centimeters less than the length. There we go. Now, if that side's x minus 8 and this side's x, well, this would also be x minus 8 and this would also be x. So we had one kind of like this on our homework yesterday. So what you want to do is add up all the sides and set them equal to the perimeter. We're doing perimeter, so the sum of the sides instead of the area where we would multiply them. So we have one side plus another side plus another side and the last side. So we can say 4x minus 8 and 8, 16 equals 42. 4x equals 58. So here's one kind of what I was talking about earlier. Like we could have guessed and checked the sides, but this one you get a decimal answer. So it's harder to find those answers when you're guessing and checking. So if I divide 58 by 4, it's not going to come out evenly. It's going to come out to be 14.5. All right, so what did that tell us? That told us that the longer side, the length, was 14.5 centimeters. So then the shorter side would be 14.5 minus 8, which is 6.5. So then what are the dimensions? 6.5 by 14.5. All right, so your new assignment, we had a textbook assignment yesterday. If you didn't get that done, go ahead and work on that. We'll check those tomorrow. And your new assignment due Thursday is page 7 through 9. Okay, so work through these. If you get stuck on one, skip it. I know there are some challenging ones in there with some tricky fractions, but see what you can do. Okay, make sure you show your work to get credit. And then does have some word problems on it as well. All right, you can email me if you have any questions. Have a great day.